So an ellipse is the set of all points x and y in a plane, the sum of whose distance from two distinct fixed points, which are the foci, is constant. The first couple of slides are just kind of explaining in words what an ellipse is. It's just this oval shape. Sometimes we'll have a horizontal ellipse that looks like this one. Sometimes we'll have a vertical ellipse that looks like this. So again, just more, bless you, definitions, explaining things. The line through the foci intersects the ellipse at 2 points called the vertices. The chord joining the vertices is the major axis, and its midpoint is the center of the ellipse. So this is our major axis. The longer one is major, the shorter one is minor. And the chord perpendicular to the major axis at the center is the minor axis. The standard form of an ellipse is centered at 0, 0, depends on whether the minor axis is horizontal or vertical. So here is kind of the most informational picture we have here. These are our focus points, these blue dots. They're always on your major axis. So whatever the longer one is, that's where your focus is. In all of our equations, we're going to have to find what A is, what B is, and what C is. C is the distance from the center to the foci. The foci is just plural of focus. So C is the distance from the center to the foci. A is the distance from the center to the vertex on the major axis. And B is the distance from the center to the vertex on the minor axis. A is always going to be bigger than B, because the major is always longer than the minor. Or it could be vertical like this one. It all just depends on where the foci are. So we have two different equations for our ellipses. When it's horizontal, the A is under the x squared. When it's vertical, the A is under the y squared. Remember, A is always greater than B. So it just depends on where the bigger number is. If the bigger number is under the y, it's going to be a vertical ellipse. So a nice, skinny, tall oval. If the bigger number is under the x, it's a horizontal ellipse. And then we use this formula here to find our C, which is the focus. So this helps us find the focus, or the foci, because there's two of them. So we're going to use this. C squared is equal to A squared minus B squared. Remember, C is the length from the center to the focus. So the last page is when we have our center at 0, 0. This is when our center is not at 0, 0. So it just has our h's and k's. That's the only difference. So just like before with a circle and a parabola, we have our h that goes with the x and our k that goes with the y. And since it's x minus h and y minus k, we have to flip the signs of whatever's in those parentheses. So we always flip the signs of our h and k. On the next slide, this is kind of step by step in words of what we need to do to find everything we need for our ellipse and how we can put it in an equation. So first thing we want to do is plot the foci. So it'll give us like 2 points for the foci. We've got to plot them depending on where they are. If our foci are here and here, we know we're going to have a horizontal ellipse. If our foci are here and here, we know we have a vertical ellipse because the foci are always on the major axis. Then we need to find the center. So the center is always going to be the midpoint of the foci. We have to find our A, B, and C. And then the bigger denominator determines whether it's horizontal or vertical. And all standard form equations are set to equal 1. So if we notice here, our equations always equal to 1. So ellipses, your equation always has to equal 1. So let's start with our examples. So we need to find the standard form of the equation of the ellipse having the foci at 0, 1 and 4, 1 and a major axis length of 6. So first thing you want to do is plot what it gives us. So I'm going to draw my ellipse over here. I have foci at 0, 1, so I stay at 0, go up 1. That's 1 point. And then 4, 1, so I'm going to go to the right 4 and up 1. That's another point. So these are my 2 foci. Step 2 on that cheat sheet that we have is find the center. So our center is the midpoint of our foci. So our center of our ellipse is in the middle of our foci. So if we see we have the length of 4 here, what's half of 4? 2. So we're going 2 from the left, so right in the middle. That's our center. What coordinate would our center have? Two, 1. So next we want to figure out our A, our B, and our C. So C is the distance from our center to our foci. So what's the length from our center to our foci? Just the length from the center to the foci. 2. So C is 2. Now it tells us our major axis has a length of 6. So our major axis from the center goes 3 to the right and 3 to the left because that would give us a length of 6. So we're going to go 3 to the right, so it would put us over here, and 3 to the left. That's our major axis. So A is our length from the center to the vertex on the major axis. So what's the length from the yellow dot to the blue dot? So A is 3, because that's the length of our major axis was 6. From the center to the vertex is half of that, which is 3. Now it doesn't tell us what our minor axis is, but we have a formula that involves A, B, and C. So once we have 2 of them, we can just plug them into our formula to find the third. So our formula is C squared is equal to A squared minus B squared. So C squared, since C is 2, C squared would be 4. Since A is 3, A squared would be 9. So then we just solve for B. So B squared is equal to 5. And B would be the square root of 5. Once we have our center and A, B, and C, we can plug it into our equation. So our equation here is, I'm going to rewrite the original and then just plug things in. So we have x minus h squared over A plus y minus k squared over b is equal to 1. Now A is under the x because we see that it's a horizontal ellipse because our focus are on the horizontal line, our foci. So now we just want to plug everything in. What's our h? Remember, h and k come from our center, so this is h, this is k. Our h is 2, so we have x minus 2. What's our a? Three. Good job. What's our k? Our k is 1, so we have y minus 1. And then what's our b? 5. Here. Our b is square root 5, but in our equation, it's supposed to be a squared and b squared. So under x, we have a squared, which would give us 9. So down here, we would have 9. And then under y, we would have our b squared. So what's square root of 5 squared? 5. So that is our equation. All right, so on your test, you're not going to have to sketch any, but it's important for us to be able to identify the center and our vertices. So we want to get this equation to look like our ellipse equation. In our ellipse equations, we need it to be equal to 1. It always has to be equal to 1 when it's an ellipse. So how can we get rid of this 36 and make it a 1?
Divided by 36.
Divided by 36. So I'm going to divide everything by 36. Hello. So I can simplify 4 over 36 and make it a 9 on the bottom. And then I have y squared over 36. 36 divided by 36 is 1. So my bigger denominator is under the y. What does that tell me about my ellipse? Is it going to be horizontal or vertical? The bigger denominator is under the y.
Vertical.
It's going to be a vertical ellipse, so it'll open like this. It'll be this type of shape. Now I know my a, since a squared is 36, a would be equal to what?
6.
6. And then b squared is 9, so what's b equal to?
3.
3. And then to find my foci, I use the formula c squared is equal to a squared minus b squared. So c squared is equal to a squared is 36 minus b squared, which is 9. So c squared is equal to 27. So c is equal to the square root of 27, which would be 3, square root 3. what would our center be? Remember, our centers are h and k, but here we don't have anything being added and subtracted to x and y. So what would our center be?
Would it be the origin?
The origin, 0, 0. So let's put a point at 0, 0. We said we have a vertical ellipse, so that means our major axis goes up and down. So A is the distance from our center to our vertex on the major axis. So we're going to go up 6, and we go down 6. And then B is our distance from the center to the vertex on the minor axis. So we're going to go to the right 3 and to the left 3. And this is our ellipse. And it doesn't tell us to here, but we could plot our foci, because C is the distance from the center to the focus, and the distance of 3 square root 3 is 5.2, so it would be like here. So if it needed to, we could list our foci there. So completing the square, we want to put all of our x's together and put all of our y's together. So we have x squared plus 6x. I'm going to leave a space in there for that number that's going to help me complete the square. And then I have my y's that I'm going to put together. So 4y squared minus 8y. I'm going to leave a space for that number that's going to help me complete the square. And I want to move all my constants to the other side, so I'm going to subtract 9 on both sides. So this is equal to negative 9. Now what do I put in my space here for me to complete the square? B over 2 squared. So our B is 6, so 6 over 2 squared. 6 over 2 is 3. So in here I'm putting a 9. But the only thing that goes into my parentheses down here is that 3 that's on the inside. So I have x plus 3 squared. But I'm adding a 3 squared into my equation, so I have to add it on the right side too. What's 3 squared? 9. So I'm adding 9 over here as well. Now I'm going to do the same thing with my y's. Y's are a little bit more tricky because I have a 4 in front. So first thing I want to do is divide out the 4. Anytime I have a number, a coefficient in front of that squared term, I just want to divide everything by that. So I'm going to divide both of these by 4 to take out that 4. So I have y squared minus 2y, and I'm going to put my number there to help me complete the square. So in this spot, I have b over 2 squared. What's my b? Negative 2. The middle number is your b. So negative 2 divided by 2 is negative 1. What's negative 1 squared? 1. But we have 1 times 4, so technically I'm adding a 4 over here. So since I'm adding 4 on the left side of my equation, I have to add 4 on my right side as well. So don't forget to multiply it by that number that you took out at the start. And then in my parentheses here, I have y minus 1, because I take whatever's on the inside of there, squared. Yes. Bless you. How did I get rid of the 4?
Yeah.
I divided this by 4 and divided this by 4. So I didn't get rid of it, I just put it on the outside here.
Right, but then once you put the y minus 1 squared, we're
Oh yeah, the 4 should be there. My bad. Thank you. And then on the right side I have negative 9 plus 4, so this would be a 4 over here. So I just added these 3 together. And then for my ellipse, I need it to be equal to 1. So what do I have to do to get rid of that 4 on the right side and make it a 1? Divide everything by 4. So now I have x plus 3 squared over 4 plus, in my y's, I have a 4 on top and a 4 on the bottom, so they're going to cancel. So it's just y minus 1 squared. I'm going to say over 1, just because that's the way my ellipse equation looks like. And then that's equal to 1. So now my bigger denominator is under the x. So is my ellipse going to be horizontal or vertical? Horizontal. And what is my center of my ellipse?
-3, 1.
-3, 1. Awesome. So I'm going to put my point at -3, 1. That's my center. Next, I want to find my a, b, and c. So a is always the bigger denominator. So a squared is equal to 4. So then what's a equal to? 2. And a is the distance from my center to my vertex. And since I said it's horizontal, I'm going right and left, not up and down. Because I'm going this way, since I'm dealing with a, and a is on the major axis. So I'm going to the left and right 2. So to the right 2, and to the left 2. Now let's find b. b squared is equal to 1. So then what's b equal to? 1. And b is the length from my center to the vertex on my minor axis. So I'm going to go up 1 from my center and down 1 from my center. So this is my ellipse. The only thing missing is my foci. So my foci comes from the formula c squared is equal to a squared minus b squared. So c squared is equal to a squared is 4 minus 1. So c squared is equal to 3, which means c is equal to square root 3. Remember, c is the distance from the center to the foci. So from my center to my foci, I'm going square root 3, which is like in between 1 and 2-ish. So kind of over here. Bless you. But again, for your test, you're not going to have to graph. Bless you. If we were to name what coordinate point our focus is, how can we do that? So if our center is at -3, 1. Our focus, we're going to the right square root 3. So I'm just looking at the right focus. So I would take -3 and add square root 3. Just adding however much I'm going to the right. And then I'm still up at 1, so comma 1. For my left focus, I start at -3 and I'm going to the left, so I would do -3 minus square root 3, comma 1. So these are my 2 points for my foci. So you always just take whatever your center is and add or subtract, depending on which way you're going. And that's how you can find your vertices and your foci, the coordinates of them. So for example 4, pretty much doing the same thing, just different numbers. I want to put my x's together and put my y's together. So I have 4x squared minus 8x. I'm going to leave a space for that number that's going to help me complete the square. Do the same thing for my y's. Y squared plus 4y. Leave a space. And I'm going to move that 8 to the other side. Just add that 8 over. So equal to 8. What should I do first with my x's? Divide the 4. So x squared minus 2x. Still need that space for what helps me complete the square. What am I going to put in here to complete the square?
Are you going to put the new number or 8?
The new number, this one. So that's my -2 divided by 2. That's my new b squared. What's -2 divided by 2?
-1.
-1, so -1 squared. So I have 4 times x minus 1 squared. -1 squared is 1, but I have to remember to multiply it by that 4, so technically I'm adding 4 on this side of my equation, so I need to add 4 on the right side of my equation too. So I'm going to do the same thing with my y's. Any questions on what we just did with the x? All right, let's do it again. So what number is going to go in here to help me complete the square? 4 over 2 squared. So I have 2 squared that goes in here. So what's going to go in my parentheses down here? Y plus 2. 2 squared is 4. So I'm adding 4 on this side. I need to add 4 on my right side too. So I have 8 plus 4 plus 4, that would be 16. What should I do next? Divide everything by 16. So I simplify when I can. For my x's, I'm going to have x minus 1 squared over 4, because I can cross those out and I'm left with 4 on the bottom. For my y's, I have y plus 2 squared over 16, and that's equal to 1. So my bigger number, my bigger denominator is under the y. What does that mean my ellipse is going to be? Horizontal or vertical? Vertical. So I want to find my center. What would my center be? 1, -2. So let's plot our point. Go to the right 1, down 2, right there. Now I want to find my A, B, and C. So remember, a is always the bigger one, so a squared is equal to 16. So what's a equal to? 4. And a, yeah.
So when you find the center, you have to swap the signs of the H and K.
Yes, you swap the signs of the h and k. Same thing with circles and parabolas too. Everything you swap the signs for h and k. So a is the distance from the center to the vertex on the major axis. So we're going up 4. 1, 2, 3, 4. That puts us down here, up here. And then we go down 4. That puts us down here. 1, 2, 3, 4. So a is always the major vertices. B is the minor. So b squared is equal to 4. What's b equal to? 2. So we're going to the left and right 2. Right 2, left 2. Oops, that would be 2. And then last thing we need to do is find our foci. So we have c squared is equal to a squared minus b squared. C squared is equal to our a squared is 16 minus our b squared, which is 4. So c squared is equal to 12. C is equal to square root of 12, which would be 2 square root 3. So we're going to go from our center up 2 square root 3 and down 2 square root 3. I don't know what the value of that is, but we'll just say it's about here. Again, you're not going to have to draw for the test, so it's just a nice little estimate to help us see, because then we can just look at our picture and name all of our vertices and our foci. So my vertices on my major axis would be on the major. First one would be to the right 1 and up 2, so 1, 2. What would my other major vertex be? Look at the picture. This point down here. 1, -6. And then for my minor, for the left one, I go to the left 1 and down 2, so -1, -2. What would my other minor vertex be? 3, -2. And then what would my foci be? So for the top one, I go to the right 1, so x is 1. From -2, so from my center, I'm going up 2 square root 3. So it would be -2 plus 2 square root 3. And then what would my other foci be? The x-coordinate's 1. What would my y-coordinate be? -2 minus 2 square root 3. Awesome. Good work.